Deleuze, are you there?
Hey, I'm here.
We are adding Sebastien. Hi, Sebastien. How you
Hi.
doing?
Fine. Thank you.
It's very late for you. Thanks again for sharing your night with us.
Yeah, that's my pleasure.
No, it's our pleasure. Yeah, just a quick introduction to Sebastien. Sebastien works very hard. Oh, I don't know how to say this. He's a frequent committer of the Spring framework, and he works frequently with Kotlin, and he is the one that introduced Kofu and Jafu DSLs to configure Spring Boot. So we are honored to have Sebastien in here with us. He will be giving us a great talk about the path towards Spring Boot in native applications. So I don't know what else to say. I think that you don't need too much presentation. You are already a rock star around the internet. I don't know if Javier has something to question or add.
Yeah, you see the difference? The Kotlin fan is like a more this lumberjack look like here, yeah. And I'm more like an enterprise user or programmer, so I'm more fond of Java and Spring. So thank you, Sebastian, to be here. I'm very excited about this topic. You may know is almost everywhere here is using Spring out there. So we are very happy to help here because everyone uses it and is the most popular probably framework for all programming languages for enterprise. So, and in this world of containers, it makes a lot of sense to have this ahead of time compilation, and we are waiting for this feature on Spring. So, thank you and welcome.
Thanks. Glad to hear that you are excited about that. Should I share my screen now to show the slide?
Sure.
Yeah,
Okay. We're on stage now. We're just here in case if anything goes wrong or something.
Okay. So let's go. Okay, so you should see my slides. Okay, so I'm Sebastien Deleuze. I'm a Spring Framework committer. I work at VMware. My topics are mostly Kotlin, the web support, so the work on Spring MVC, Spring Web Flux, and these days I'm working on the GraalVM Native support, and that's mainly what I'm going to show today. So the talk today is called The Path Towards Spring Boot Native Applications, and we are going to talk about GraalVM Native, Spring Boot, and how these topics fit together. This is just a standard statement because what I'm going to show today is R&D work and is likely to evolve. The agenda will be, we are going to talk about native applications outside of the Spring Boot context. Then we will make a focus on how does it apply to Spring Boot and what I call Spring Boot native applications. I will explain where we are in terms of support today, how to getting started with a new or existing Spring Boot project, a demo of Pet Clinic sample running as a native image, a focus on Spring GraalVM Native, and we will talk about the road ahead, so basically the roadmap and the next steps. But let's start about native executables. So GraalVM is a project started several years ago by Oracle. It allows, among other things, to compile Java, Kotlin, or any kind of JVM application to a native executable that can run on its own without the need for a full Java virtual machine. This is done by the GraalVM native compiler, which is a subset of GraalVM project, which has a wider scope. And the main use case, I think, is to build lightweight container images. I think there are two main advantages in doing that. The first one is instant startup. So here, our goal is to scale to zero That means you only pay when your application is used. That basically serverless for any kind of workload, including for regular web applications. So it really depends of the kind of application you are developing. For functions, that's no-brainer. For microservices, that could be interesting. For back offices application, not used 100% of the time. Let's say if you have a back office that is used half % of the time, that could be a way to reduce the cost. And that's also a good fit with Kubernetes, with platform like Knative, which are natively designed to start a container when there is some workload. The other advantage is reduced memory consumption. So we observe between 3x to 5x memory reduction in terms of RSS. That's allowed to have cheaper cloud instances. And I think that's critical with systems split into multiple microservices, because basically where you split such system into a lot of microservices, the cost of the GVM for each microservices became a problem in the cloud, I think. So why these new capabilities are super exciting, we need to keep in mind that GVM and native provide basically different trade-offs. So I think it depends on your workload, at least today. So while native executables really shines in terms of startup time and memory footprints, GVM still offer better performances and is more mature, obviously, even if GraalVM is evolving quickly. And in terms of build, that's very different, because native compilation take a lot of time, so multiple minutes for a typical GVM application. It's also consume a lot of resources. So the key point here is that you will not use native executables for a fast development cycle. I think you will continue to develop on the GVM, because that's a faster, that's more efficient. And then the native compilation is more an optimization step when you are creating your container. At least that's the way I view it. So let's now talk about the key differences between GVM and native, because we have basically two flavors of Java, and obviously the goal will be to reduce the differences, but currently there are some differences and some will remain. So the native compilation is basically doing a static analysis of your application from the main entry point, so basically your main method, and it will remove everything that is not used explicitly, because the goal here is to create a very small executable that consumes not a lot of memory. So additional configuration will be typically required for reflection, proxies, and resources, and whatever libraries or framework you use for non-Hello World application, those elements will be required. It could be done automatically with GraalVM native support. It could be provided manually by yourself if you want. The class path is fixed at build time, so that's important. The class path will not change at runtime, but that's typically the case for typical Spring Boot application deployment. So that's not a big constraint. Another key difference is that there is no class lazy loading. You know, in the GVM, a class is loaded when it is used. On the native image, every classes shipped in the native image are loaded at startup. So hence the goal to optimize things at build time and remove as much as classes we can, because everything is loaded at startup. And another significant difference is that some code will run at build time, because some classes can be optionally initialized at build time, mainly for optimization purpose. So I think GraalVM native is a source of inspiration for the GVM ecosystem, especially when you want to target containers. So that's interesting, because that creates new opportunity to improve the efficiency of our Java application, Java or Kotlin application, when deployed on container, typically on Kubernetes. But the scope is wider than just GraalVM. There is an upcoming Java platform standard, which is Project Leyden. So Project Leyden is not exactly GraalVM, but that's a similar ahead of time native compilation that will share some common characteristics with GraalVM. So that's pretty interesting to see that in the future, this kind of deployment will be part of the Java platform standard and will be part of OpenJDK itself. So let's now talk about Spring Boot's native applications. So what I mean by Spring Boot native application is when you want to compile a Spring Boot application into a native executable using GraalVM. First, I think that's a pretty good fit with Spring Boot's standalone deployment model. Currently, it's mostly used with an executable jar that you deploy on a container or on other platform. But really, this standalone executable is a pretty good fit, I think, with Spring Boot's regular deployment model. Compiling your Spring Boot application to a native executable will require reflection, proxy, and resources configuration. But the good news is that the Spring team is doing most of the hard work for you, and that's what I'm working on with other people like Andy Clement, Dave Sayer, and other people. So this is maybe the most important slide of the talk. Our goal is really to support the compilation of existing or new Spring Boot applications to native executable with GraalVM Unchanged. And we are not here yet. That's a big challenge. But if we succeed, and I think we will, really the scope is pretty huge because we are not talking about new shiny applications. We are also talking about existing applications. And that's why our work is pretty hard, because we want to do that without breaking your application, your Spring Boot application. And that's a pretty interesting challenge. So we have been collaborating with the GraalVM team for the several months, and that has been a very intensive and efficient collaboration. Here is a quote from Thomas Versvinger, the GraalVM founder and project lead, who said, "We are excited about the great partnership between the Spring and GraalVM engineering teams to support native ahead-of-time compilations for millions of Spring Boot applications. This is a game changer, enabling low memory footprint and instant startup for this workload." So you can see that, like us, the GraalVM team is pretty excited about the possibility to target native images with Spring Boot applications, because the scope will be pretty huge. And we continue to collaborate with the GraalVM team in order to achieve this goal. So concretely, how do we plan to leverage Spring Boot support for native images? We plan to leverage existing capabilities to build container images. So you have these commands like Maven, Spring Boot build image, or Gradle boot build image. And by switching a configuration flag that I will show a little bit later, you will be able to build a container that, instead of the JVM and your Spring Boot classes, will contain a native executable. Underneath, this is done using Paketo build pack, which is the new generation of build packs based on container and typically designed for Kubernetes. Here, we have been implementing a lightweight container using a very thin base layer. You can see that the base OS is less than 20 megabytes. So it's Ubuntu based, but using only 7 packages optimized for security and size. And on top of this minimal OS, we add the application, which is here a Spring MVC with Tomcat application. The application itself is less than 50 megabytes. And you see that the total image size is 67 megabytes, which is pretty optimized. So that's what we are using underneath. So concretely, where are we in terms of support? So like I said, we have been collaborating with the GraalVM team because the first step was not to implement GraalVM support on Spring. The first step was to fix GraalVM native, which is pretty young, in order to support the Java features that we need for Spring, because some features of Java are not supported on GraalVM, but the one that are supported, there was some problems, some fixes, some improvements to do in order to be able to run just the regular Spring applications. So we have been collaborating with the GraalVM team, and most of the fix has been done. And now we are more at a step where we try to optimize things. So better compatibility and more optimal efficiency. The current main step is incubating support in Spring GraalVM Native that I'm going to present a little bit later more in detail. And our goal is really to incubate and mature our support in this experimental project, and then to directly integrate native image support deep in Spring Boot, Spring Framework, Spring Security, Spring Data, and other Spring projects. And this step has already begun. If you want to have a deeper look to the slide the issues that we have already fixed, you can see you can go to this URL and you will see the issues that we have already fixed and the one that are still opened. You can go to github.com Spring Project Experimental Spring GraalVM Native. That's the home of the incubator, when you can follow our progress, go to issues. We have an up-to-date roadmap that you can watch, and you can obviously provide pull requests and create issues. So this Spring GraalVM Native project is basically an incubating Spring Boot native application support. It includes a plugin for the GraalVM native image builder. It analyzes the Spring Boot application at build time, and it computes the most optimal native image configuration. The challenge is to do that with a static analysis at build time, because usually with Spring Boot application, it will be done at runtime. So there are challenges in doing that, but we are doing good progress. And we also perform some build time transformation in order to have an optimized footprint. So here the goal is more to remove the classes that we know that will be not used at runtime, because like I said previously, every class is shipped in the native image will be loaded in memory. And we also use some transformation in order to improve the compatibility, to basically change some construct to be compatible with GraalVM Native. We have just released Spring GraalVM Native 0.8.1. It's based on GraalVM 20.2. It's used Spring Boot 2.4 latest milestone, and we will continue to follow Spring Boot milestones, release candidates, in order to reach the GA, which will be released in November. We have done significant footprint improvements, wider range of supported technologies. So there is beginning of support for actuators, Spring Data, wavefronts, and Spring Cloud Function. There is a new experimental functional mode that I will present more in detail at the end of the talk. And we have the Spring Boot lightweight container integration that I have presented before with Maven or Gradle support. There are also new flags available in Spring Framework 5.3. So we have a flag to in-your XML support that provides some interesting gain in terms of footprint. There is also a flag to in-your spill for so this is Spring expression language, and when you don't need it, this flag allows to remove it. Currently, you have to set this optimization flag manually, but our goal is basically to analyze your application and later, in a later version, to automatically set those flags and additional ones to remove more feature at build time. We are not only working on Spring, and really our goal is not just to provide native image support in Spring and put all the value in Spring. Our goal is also to increase the support for native images in the ecosystem, in the GVM ecosystem. And we really believe that each project, each library needs to provide better support and better testing on native image. So we are working with the GraalVM team on improving testing capabilities, but we are also contributing into to open source project where we are involved, like Tomcat. So for Tomcat, for example, we have contributed this Tomcat embedded programmatic artifact, which is basically a variant that is using programmatic construct instead of reflection. And that's something that the native image compiler can analyze automatically. And the result is a smaller footprint. We have also a CI that checks Java 8 and Java 11 builds on both GraalVM 20.2 and 20.3. So we really try to have an extensive testing based on the sample that we currently maintain. So concretely, when you start a Spring Boot application, how can you start with these things? So you will go to start.spring.io or on an existing project. Currently, only a subset of starters are supported, so that's why we need to continue to add more support. But basically, you can see the scope, watching the documentation and trying the current samples that we support. Make sure to use the latest Spring Boot 2.4 milestone, because some GraalVM native support requires the latest Spring framework and Spring Boot version. Things will be simpler when we will be at the 2.4 GA stage. And update your configuration to avoid using proxies. It's not possible to use CGLib proxies because this kind of proxies are created at runtime, and that's not supported by GraalVM native. So if you compare this code sample to regular Spring Boot application, you see that here we have to add this proxy bin methods equal false. That's a signal for Spring to not create a CGLib proxy, because here it is not needed. So currently we have a switch to this proxy bin methods equal false in all Spring Boot configuration, and you already need you just need to do that in your own application. We have ongoing work to set it automatically via built-in transformation, so you will just be able to use add Spring Boot application or add configuration without setting additional attributes like that. In terms of configuration, you will configure your Spring Boot Maven plugin to enable native image build like that. You can optionally specify the Spring GraalVM native dependency, but if you don't specify it, the Spring Boot native builder will add it automatically. And you will build the application like that, Maven Spring Boot build image. It will take between 1 minute and several minutes. It depends of the size of your application. There is no need for a GraalVM native install, because everything happens in a container and it will produce a container image. And then you will just run your application using Docker run or Docker compose or any kind of container-based arrangement. The key point here is that you see that the build takes a lot of time, but your application starts almost instantly. But you can also build a native executable without using containers. So for that, you can leverage native image Maven plugin. So this is the plugin provided by the GraalVM team. You specify the main class, and then you have an executable. You build with Maven-p native in this sample clean package. So here, there is a need for a GraalVM native install. The build happens directly on your host, so Linux, Mac, Windows are supported. And no cross compilation. So if you build on Windows, you will produce an executable for Windows. If you build on Linux, you will produce an executable for Linux. That's why we are more interested in the container-based arrangements. But if you prefer that way, no problem. And that will just provide a native executable that you can run like that, and you have the same instant startup behavior. So let's go for a quick demo. So we have a project which is a pet clinic typical sample. So you can see that that's a regular Maven project. We are using the latest boot milestone. Here we have the dependencies. I'm just going to the specific bits. So here you can see that we are using, so this one is to basically use the tiny image with only, like I said, less than 20 megabytes of optimized OS. Then we say that we want to enable native image support, and then we can optionally add some native image compiler arguments here. Okay. So that's it. You can see also that that's a regular Spring Boot application using using annotation. So it's not the functional stuff I'm working on Spring Foo. Here we are really talking about a regular Spring Boot application with annotation-based controller, etc. And in order to build it, we are going to run Maven Spring Boot build image. So here, this is a command that will build things, run tests, and then perform the native image compilation. Since I did the compilation previously, the creation should be pretty fast, because here it is. It should be in cache. Okay, so here you can see if you have modified the application or for concrete use case, the build will typically take a few minutes. So if here we have our container image. I'm going to start. So you can see that I have. Let me show you Docker Compose. So here I have created a Docker Compose where I have my MySQL server and my pet clinic JDBC application, okay, which is using the name of the image that I have generated, which contains a native executable. I'm going to start the MySQL server, and I'm going to start my pet clinic application. So you can see that it starts almost instantly. And if I go to localhost, you can see that's my typical pet clinic sample that I can use like on the GVM. So here, that's my goal was really to show you that you don't need to change all your application. Obviously, we don't support yet all the different Spring Boot starters and dependencies, etc. But our target is really to support existing Spring Boot application unchanged, with just some configuration to create a container using a native executable. So the difference is that we have a longer build, but I think that in production, this build will be mostly done on the CI/CD platform rather than on your laptop. Obviously, we need some kind of testing on the laptop, but the development cycle will be pretty long. So the goal is really to use that as an optimization to create more efficient containers images. You can see that in terms of memory, the gain is pretty significant because we have something like 75% of gain in terms of RSS, which is the total amount of memory, and we still have more optimization to do. So expect these figures to go even lower. And the startup time is instant, so it's possible to use this kind of a container with Knative or other platform that really pop up your container as soon as there is some workload, and then shut down it to basically have cheaper hosting. There is ongoing work at footprints. So here you can see the figures that we had last year and the figures that we have this year. And our expectation is that next year, when we will show the figures, we will be even better. So just keep in mind that we are still in the middle of optimizing things, and that the footprint and the compatibility will get better and better. If you need to specify additional native configuration on your side, because us with Spring GraalVM Native, we are basically automatically configuring Spring Boot, etc. for native image, but maybe you need to add more configuration for your own stuff. For that, you can just leverage GraalVM Native configuration capabilities. Typically, you create some files, some JSON configuration files in meta-inf native image. Here is an example for the resources. You can do the same for reflection and proxies, and then you will just configure these things. Okay, so let's now talk about the road ahead. So our next big step is in December. We will release Spring GraalVM Native 0.9, and this is our first release with the beta status. So beta status is that we consider that with a certain subset of starters, you can begin to try it with your project. And if you have some issues, you create issues, and we solve that. Currently, we mostly focus on different samples that we use as drivers to we use that to test our support and improve our support. And in December, we will be ready to allow you to test that with your own project. Obviously, you can do that today, but we believe that the support need to be polished a little bit more for real world use case, I would say. After that, breaking change will happen. But we will provide upgrade paths. So if you are an early adopter, the goal is to allow you to go native with Spring Boot 2.4, maybe 2.5 later, and Spring GraalVM Native. no need to wait future versions. There will be a wider support, so Spring Security, Spring Batch, and we will provide a development-oriented container image in order to debug or do similar things. More starters will be supported in upcoming 0.9 releases. So in 2021, next year, we will release 0.9, 0.1, 0.2, 0.3, etc. to improve and refine our support in order to improve the quality of our native image support. Now, I would like to talk about more another step that could increase even more the footprint and the compatibility. It's the functional bin registration, which is something that is a kind of hidden gem. It's in Spring Framework since 5.0. I have used that in my work on Spring functional application in Spring Foo, Kofu, Jafu, if you have followed my work. But here, maybe we have a way to leverage that for regular Spring Boot application based on annotation, and I'm going to explain why and how. So at the left, you have the add configuration, add bit configuration model that is used typically in Spring Boot configuration to declare the various bins. So here we are declaring a bin foo, a bin bar, and there is a dependency between both. And for a human, that's pretty easy to read it. For a native image compiler, that's pretty hard. At the right, you have the functional variant, which is, especially in Java, a little bit harder to read, but the native image compiler can understand it automatically. So better compatibility, better footprint, because there is no reflection configuration. Yeah, that's a better fit, basically, to create bins using Lambda like that, because the native image compiler can analyze that. So the idea I would like to explore is how if we would convert the add configuration model of Spring Boot to the functional configuration in a kind of automated way. The good thing is that we have been working for more than 1 year on that. So Dev Sayer and Andy Clement has created the Spring Init project, which is another experimental project that we have. And Spring Init goal is to automatically convert at build time Spring Boot configuration and also your configuration in your project into something that is using only lambdas that can be automatically understood by the GraalVM native compiler. And this is not yet our default mode, but we have some promising samples. So if we compare the regular variant with the functional variant, I mean, there is no change in your project. It's all build time transformation done automatically behind the scene. You can see that we have almost 50% of decrease in terms of memory RSS. That's why we want to continue to mature and improve this way of supporting native application, and maybe later it could become the default. We plan to experiment more on more build time transformation. So in addition to this mechanism, we plan to support add configuration without CGLib proxies out of the box. That's almost ready. Automatically set optimization flags and other kind of build time transformations. And while we are going to provide support using Spring GraalVM Native on Spring Boot 2, 2.4, 2.5, our goal is to provide a first-class support for native application deployment in Spring Boot 3, which will be based on Spring Framework 6. We will provide and communicate in the upcoming months more about what that means. And our goal will be also an optimized footprint on the GVM. So here is the takeaways of this talk. So Spring Boot native applications are great to build lightweight containers. You can try it now with Spring GraalVM Native 0.8.1. You can contribute support for your favorite starter. We have a documentation that explains how to contribute that. The beta status will be reached in December with Spring GraalVM Native 0.9. We will have wider support in upcoming releases, and we will have a first-class support without the need of Spring GraalVM Native in Spring Boot 3 and Spring Framework 6. But again, there is no need to wait this future major release. You can already begin to try it with our Spring GraalVM Native effort. I think that's it. I just share the link to the repository. I will publish some blog posts with Andy Clement about our efforts, and you can follow me on Deleuze on Twitter for more fresh news. So maybe there is a Q&A now.
Yeah, sorry, I just removed your screen. I see that you were trying to do that.
Yeah, thanks.
We have 3 questions right now. So I will read one from Javier Sainz, but I prefer that Javier Sainz read it because he asked it.
Okay. Yeah, I have 2 actually. One is like is the Spring unit is a similar approach what to the Micronaut and Quarkus style that they are like doing compilation ahead or doing code, around your annotations and that kind of stuff.
I mean,
Project that you mentioned.
yeah, I mean, the point is that GraalVM Native, if you want to have an efficient GraalVM Native support, you need to do built-time transformation if you are using annotation-based programming model. I mean, if you are using programming model based on lambdas like Spring Foo, etc., you can avoid build-time transformation because basically your code is automatically understood by GraalVM compiler. If you are using Spring Boot typical programming model, which other frameworks also use with annotations, things like that. I mean, that's something that is widely shared now. You need some built-time transformation in order to remove the unused classes because, like I explained, you need to remove the classes before because everything will be loaded in memory, and you need to add that thing. So this is a common requirement for efficient support for native image for all JVM frameworks. What we do specifically in Spring Init is basically transforming our add configuration programming model to something that is using lambdas, basically in order to basically get the efficiency that you have with Spring Foo, but with regular annotation-based programming model without changing your application. So I think that's a little bit different. But globally, yeah, if you are asking, yeah, we are going to use more built-time transformation because that's a requirement to have a good GraalVM native support. And yeah, that's something that happens in other frameworks, like you said.
Cool.
Okay.
I will ask.
I have one more.
No, first another person, and then you again.
Yeah.
It says Rogelio is asking. I'm under the impression that once that you are able to compile Java to native code, you should be done, right? Why more work needs to be done for Spring Batch, for example?
It's because I mean you need a dedicated native image support. So that's what we are working on, what Quarkus and Micronaut are working on as well. Because basically, if you are using not just basic Java features, you need more configuration. And what we try to do with our current effort is to try to minimize the amount of configuration that is needed to get Spring Boot application running on as native image. That's why we are working on this Spring Init effort to basically, because currently for all the auto configuration, we need to configure GraalVM to understand it, because the native image compiler is not able to understand what part of the code are used, and basically we need to help him it to understand that. And that's why we have to perform various configuration for all the Spring Boot auto configuration, because otherwise GraalVM native compiler shrink everything that is not used explicitly, and it is not able to understand how Spring is using add configuration in Spring Boot and in your application. So currently we need to add support for Spring Security, Spring Batch, etc., by adding some hints that basically help the native image compiler to understand how add configuration will be used, or how add controller will be used, etc. What we plan to do with our more ongoing work is remove a large amount of configuration and do some built-time transformation in order to basically transform the annotation-based programming model to something based on Lambda that basically native image compiler understand out of the box, and that improves the compatibility, because with that we have much less support to add, less ints to add, and less manual, not manual, but less automated configuration to do. Everything works more out of the box, but that's a significant effort. That's why we have started that 1 year ago, and currently we are able to convert all the Spring Boot auto configuration into Lambda-based variants. That's already done. But we need to do more changes in Spring Boot and Spring Framework in order to improve the native image compatibility. And also we need to configure, need to collaborate with the GraalVM team to improve GraalVM for better support, because some features currently not supported by GraalVM Native will be supported, and that will make it easier to support Spring Boot application. And the last point is that we need to keep our programming model, because our goal is to support existing application, existing programming model that everybody is using in the world. And the big challenge that we have is to support this native application super efficiently without breaking the programming model that already exists and all the API that we have already published. And that's the work we are trying to achieve.
Awesome. That's a lot of information, and that's very interesting that you are working together to just manage that it will improve. Both teams will improve their product, and that's amazing.
Yeah.
We have another question from this guy over here. Yeah.
Sorry about this question, but I'm very curious about how important is compile in the architecture. I mean, architecture is the hardware architecture where you will run the application. Like, for example, I can compile my Docker image here on my computer, but the CPU is very different to what we have in the cloud. So do you think that is very important, or is not crucial for this?
It's maybe a little bit too early to say. I tend to think that later it will be more. I think the compilation could be done locally for testing, etc. But I really see that as part of the CI/CD platform, or even on the hosting platform. Basically, native images are not suitable for all workload. If you are Netflix or PayPal and you have a huge amount of workload used 100% of the time, I'm not sure native image is a good fit even for containers. But if you have microservices, if you have back offices not used all the time, maybe we can imagine some mechanism that basically it notifies the kind of workload that makes sense to be as native image, and this to happen automatically in the Kubernetes platform, and that's what we are working on.
Okay, thank you.
And the last one from Rogelio again. What is the native compiler technology that it is being used internally?
I'm not sure to understand the question. I mean, we are using GraalVM Native, the latest stable version 20.2. We can use 20.3. We are testing that, and we are testing the various variants, but I'm not sure to understand native, the question.
Yeah, I don't know what it means.
Yeah,
Sure.
It means who generate the machine code, and I think it's GraalVM.
Yeah, this is really GraalVM, and basically all the GVM frameworks that support native currently are using GraalVM native compiler underneath, and that's the common ground for native image support. Maybe later Project Leyden will bring an additional support, which will be a little bit different on the GVM. But currently, yeah, every Java to native application is using the same basis. There are some variants, there are some forks, there is an enterprise version. But basically, hey, basically every native compilation is using GraalVM Native, and everybody is trying to adapt to this new compilation platform.
Sure. It makes sense now that I see it in that way. Cool. Okay, we are running out of time, but thanks again, Sebastien, for your time, for amazing content, and for sharing with us, for having your night with us. We know that it's very late for you, but thanks again.
Yeah, that was a pleasure. Thanks a lot for inviting me.
Yeah, it's hard to have the heroes here, but thank you so much. Yeah.
Thank you for inviting me.
If you have more questions, find Sebastien on Twitter. Search for him. We are gonna share his content as soon as we can. And thanks again.
Okay, bye-bye.
Well, going back to Spanish. Regresamos en regresamos en 5 minutos. Vamos a seguir ahorita con las pláticas y lo siguiente será algo interesante. Estamos justamente en el canal de arquitectura y de JVM Languages y vamos a hablar justamente de construyendo una API en Clojure con pedestal. Va a ser algo interesante. Entonces quédense aquí. Regresamos en 5 minutos, tal vez 8. Regresamos.
Órale.
Sale Sainz.